In this lecture, I'm going to be talking about name entity recognition again, but we use Fewshot learning. Also, we use the incremental learning, and the way that we use Fewshot learning is by using prototypical network. I'm sure you have seen my video about ProtoNER in the playlist for Fewshot learning. And so in this lecture, I'm going to be focusing on this important paper, ProtoNER, Fewshot incremental learning for name entity recognition using prototypical networks. The key value extraction or name entity recognition from visually rich documents has been an active area of research in document understanding and data extraction. Several transformer-based models have emerged, achieving state-of-the-art results. However, addition of even a single new class to the existing model requires reannotation of entire training dataset to include this new class and retraining the model again. They present ProtoNER, which prototypical network-based end-to-end KVP extraction model that allows addition of new classes to an existing model while requiring minimal number of newly annotated training samples. The key contribution of their paper is that no dependency on dataset used for initial training of the model, which alleviates the need to retrain original training dataset for longer duration, as well as data reannotation, which is very time-consuming task. No intermediate synthetic data generation, which tends to add noise and result in models' performance degradation. Hybrid loss function, which allows model to retain knowledge about older classes as well as learn about newly added classes. So, given a set of n classes, a model mk is trained on k classes. And then train a new model mk plus j, train on k plus j classes. So it's a dynamic work. We incrementally add new classes, but we don't retrain everything from scratch again. The current deployed model is that addition of new classes to already trained classes. How to enhance the understanding of the model to support 3 additional classes. So we have 3 additional classes that we are adding to our classes, but we don't want to learn everything from scratch again, because now we have this amount of classes instead of the original 4 classes. Now we have 7 classes. But in continual learning, we have a problem of catastrophic forgetting. So in conventional training, adding a new class requires the annotation of the entire dataset to incorporate these new classes. Adding new classes to already trained model may introduce a catastrophic forgetting problem where model tends to forget the knowledge acquired about older classes while learning about new classes. To alleviate this problem, they incorporate a hybrid loss function that combines cross-entropy loss and cosine similarity loss. Cosine similarity loss is only applied to older classes during addition of new class, which forces the model to retain the knowledge about older classes, whereas cross-entropy loss allows the model to learn about new classes at the same time. It also helps the network not to overfit on the Fewshot instances, as well as not becoming biased to the base classes. This is the architecture of ProtoNER. This is the last hidden layer. But for each of them, we have, for example, if we have 3 classes, we have 3 classification. 3 classes is a classification layer. And to convert layout to prototypical network, last hidden layer is leveraged during training as well as inference. While training a model, if a token with ground truth label C sub 1 gets classified correctly by the classification layer, class hidden layer representation for that token is saved as a prototype for key class C sub 1 under the prototype pool as shown. And so this figure highlights the overall training procedure for our model, which consists of two steps: base training and incremental training. So here we are adding a new class, C4, instead of just only C1, C2, C3. We are adding a new, so this is the incremental training stage after we do the base training. Because now we are adding, so we just need to have this cosine similarity, but only for older classes. So during the incremental training phase, to add new class to the base, the prototypes saved for the older n classes are carried forward as is and not updated at any point of time during the incremental training. Only the prototypes pertaining to the other classes are discarded before initiating the incremental training. And you see, for example, currency has the frequency of 1000 and different frequency of key presenting purchase order dataset. So their base train examples is just 2600. And the number of classes in the base is just 4, but they add 6 more classes, so it becomes 10 classes overall. And they record the precision recall on F1 for their model, which is ProtoNER. And for some classes, we have a relatively small F1 score.